Okay, alright, I'd like to look at a second example. This time we're solving the equation sine of theta is equal to negative 0.8. Again, if we had a nice number here, sort of a recognizable y-coordinate on the unit circle would be something like a negative a half, or negative root 2 over 2, or negative root 3 over 2, or even a negative 1. We don't have that kind of number. We have some, well, sort of weirder looking decimal number. So we won't expect our solutions theta to be nice and recognizable angles on the unit circle. There'll be some other angles instead. And the natural way to do this is by looking at the unit circle. We'll do this using graphs just like we did in the previous example too. But negative 0.8 for the y-coordinate on the unit circle. Well, there's where y is negative a half. So negative 0.8 is probably somewhere down here. We'll just write that, negative 0.8. So we're looking for two solutions. One is right there, somewhere in the fourth quadrant, and then the other place where there's a point on the unit circle and the y-coordinate is negative 0.8 is there. So these two dots, the dots themselves aren't the solutions really. It's that there's this angle. Again, we have to make sure, you know, we're drawing counterclockwise because we want an angle that's positive, something between 0 and 2 pi. There's one solution, and then the other solution is really like that. So at least we have a picture of the two solutions that we're looking for. One angle is going to be between pi radians and 3 pi over 2 radians. So how do we begin to find this? Well, this point has x-coordinate. Well, we don't really care, so let me just sort of draw a scribble there for that. But the y-coordinate is negative 0.8. This point as well has x-coordinate. We don't really care. And the y-coordinate is again negative 0.8. In fact, the two, if you wanted to find the x-coordinate, what you do to find the x-coordinate is use x squared plus y squared equals 1. But again, we don't need that. And if you did go through that, you'd get two possible x values. And don't forget, when you square the plus or minus sign, the positive one would go here, the negative one would go there. The whole point of going through that argument is to say that here the reference angle is going to be the same as right here. And again, maybe my picture isn't doing this so well. Well, maybe my picture's actually okay this time. But yeah, so we have these two red arcs, which I think I just drew this one in closer, but these two angles are supposed to be the same reference angle. And the thing to really do for this particular problem is to take, well, let's take this point in the fourth quadrant and flip this up into the first quadrant. You get a point like somewhere over here, and again, who cares what the x-coordinate is? It's the same x value as here because you move the same amount east. But the point is here, the y-coordinate is 0.8. So we have this angle over here. And so why even deal with this angle in the first quadrant? Well, first of all, it's related to the other two angles. Okay, so this angle has the same reference angle as these other two. And this is not one of the solutions we're looking for, but it's nice. It will be nice to use this along the way. So we're gonna go ahead and just find what this angle is, okay? Because so this angle right here, let's just call this angle alpha. Alpha happens to satisfy. Right, we'll write this in words, but alpha satisfies sine of alpha is equal to positive 0.8. The key is positive right there. And so then when you go ahead and switch, you have sine inverse from the switch of 0.8 is equal to alpha. And so there's our angle. Alpha is sine inverse of 0.8. And we said that sine inverse of a positive number is an angle in the first quadrant. I did this in Google, and well, I guess I didn't yet. Let me type this into Google. And if you type arc sine of 0.8, then you'll actually get that this number right here is approximately 0.927 radians. Now, you don't need the number itself to finish this problem, but it's just sort of nice to keep in mind that this is a number. Well, if you know this angle, then you actually can figure out what the two angles we're looking for are. So this first angle, let me label this in green, in the third quadrant that we're really looking for, well, this is, think of reference angles. This is pi radians plus whatever's in red, and whatever's in red is this angle in blue here. So this green angle, and I can't mark this. I'd like to mark this over here, but instead I'll just label that information right here. This really has to be pi radians plus this angle alpha in blue. So you could write 0.927, but we won't do that. Here's the exact value, sine inverse of 0.8. What about the other angle we're looking for? If I mark this in, I don't really have another color to work with. I'll just use, let's just use let's just use blue. I hope that's not going to be too distracting, but if I sort of draw that angle right there, let's see, so to get this angle, well, this is almost the entire 2 pi, it's just 2 pi less this red angle, which is the reference angle, which is again right here. So I think I can actually afford to label the angle itself, and the angle is going to be 2 pi in this case minus the reference angle of sine inverse of 0.8. Now we solved this question using the unit circle, but you could do the same question again by looking at the graph of sine. So y equals sine of x looks like, let me try this again, it looks something like that. There's 2 pi, halfway in between is pi between this x-intercept and that one, and then halfway in between here has to be the top of this upper bump, and that is actually then, well, halfway in between has got to be pi over 2. We're looking for where the y-coordinate is negative 0.8, so here's where, if we were to label this, this is negative 1, and negative 0.8 is somewhere not too far from there, right? We're looking for, well, I should actually just make this a solid line, and we're really looking for that and that. Okay, and we might as well label this right here that this is actually, 3 pi over 2. So this is the first solution that we're looking for. But here's what you can do. So imagine you start here, and again, this is not usually the sort of rotation we do to talk about why sine is odd, but go ahead and rotate around this point. So if you were to travel, in this direction, and in this direction, you travel equal and oppositely. So as you travel along, you get to this point, by going to the lower right. If you did the same thing in the upper left, you get to this point right there. And if you keep traveling, you turn past this curve and you get to this other point. So same thing, keep traveling, turn past the curve, and you get to another point. Sorry, my picture's not the best, but you get one right over here. And what's the point of that? This is actually, well, due to the mirror, due to the symmetry that's going on, this would actually have to be, whoops, this right here would have to be positive 0.8. So when you take sine inverse of a positive number, you get an angle that's between 0 and pi over 2, and so this one right here actually has to be sine inverse of 0.8, positive 0.8. Okay. And if we were to try to use the same colors for correspondence, well, that red thing right there is actually then this distance right there. And you actually see copies of this red distance. So what is this? This was after the turn, and then keep going until you get to the intercept. So this is after the turn from this point, like this point right here, and until you get to the intercept. So that's actually this distance. And then if you want to copy this distance, which appears one more time, from intercept to the angle, go ahead and, instead of rotating the graph of sine around this point, flip the graph of sine around 3 pi over 2, and then you'll see that this line segment would actually end up right there. Okay. So one of the angles we're looking for, now we can start to actually label, is this one in green. And so what is that? So the green here, you start and you travel pi radians already, and then the reference angle amount. So pi radians already, right up to there, and then the reference angle amount. And look, this piece that's in red right there corresponds to this piece that's in red. What about the other angle, which is in blue? Well, to get this big angle, which is almost the entire 2 pi, where do you stop? Right when you approach the red. So you keep traveling, you get this really big angle until you get to almost the 2 pi, but you stop right when you get to the red right there. And so right here, for the same reason, you can actually, label that this really has to be 2 pi. This angle right here has to be 2 pi minus sine inverse of a positive 0.8. And back here, this green angle that we've labeled right there, well, that has got to be, well, this was go up to pi and then go that additional red distance, and that red distance was this angle over here. So that's got to be pi plus sine inverse of 0.8. So you see the same solutions, right? Theta equals that as one solution, and theta is equal to this is the other solution. There are two solutions to this equation, which are between 0 and 2 pi.